Okay, looks like we are online. So, welcome everyone to a webinar here, which is actually a workshop where we would be discussing about rapid RAG optimization. And we would be today building a RAG on Quadrant, and we would be evaluating this RAG solution with the help of Quotient AI. So, together with me, I have Deanna Emery from Quotient AI. So to kick things off, I'll start with probably like a short intro of myself. So my name is Atita Arora, and I work as a solution architect at Quadrant. I come along with 15 years of information retrieval experience in the domain, helping clients implement the information retrieval systems, and currently been helping a lot of customers with implementing a successful RAG solution in production. And maybe to help me here, how about a short intro from your side as well, Deanna?
Yeah, I am Deanna Emery. I'm founding AI researcher at Quotient AI. And I've been in the AI and ML space for the past 6 years now. I'm based in Boston. And yeah, that's me.
Great. So without further ado, let's get into it. Okay, so a short agenda about what we would be doing today. Of course, we've covered the introductions already. Yes, we have to go through the boring what is RAG. We have to do that because probably it is relevant for some people who are probably getting to know about RAG for the first time. So we would be building naive RAG in this workshop today. We would be walking you over with the code from our Jupyter notebooks, and we would be discussing about how can you evaluate your RAG solution. And Deanna is going to be helping us figuring out like how we can do an incremental experimentation to optimize our RAG pipeline. So let's get into it. Yeah, so this is the slide probably might have seen like gazillion times already, and people who have been working on RAG, unfortunately, this is a live session, so I cannot ask you to raise hands, but I'm sure many of you have been already experimenting with building RAG. And it's an interesting technique. So retrieval augmentation, augmented generation basically brings the large language model, like the generation capabilities that large language model has with the capabilities of the vector databases, which has strong capabilities of knowledge retrieval together to generate a more relevant and grounded response to the user query. So going forward, because we spoke about vector databases, I think that's a perfect hook for me to introduce you to Qudrant, which is an enterprise-ready, massive-scale vector search database, which is focused on performance, scalability, and resource optimization. If you would look at the stats, which are displayed on the right-hand side of your screen, I might as well say that it's the most loved vector database engine right now. It's quick and easy to start with, and it's a fully open source project. All the embeddings are supported out of the box. Coming to the performance-centric part, it provides you with the exceptional performance to handle the vectors natively. And it also helps you handle the complexity of billion-scale vectors. It has support for the dense as well as sparse vectors, along with the one-stage filtering supported out of the box, including for the geolocations. From the resource optimization focused aspect, we support several quantization techniques which help you save memory and speed up your search up to 40 times. And it also has the advanced scalability provision where you could also do the custom sharding based on the payloads, as well as the deployment flexibility is also there. I know we're talking about RAG today, so I'm sure you must have seen like several different ways in which RAG could be implemented. We would be discussing the naive RAG, as I said before. There are other techniques, for example, the advanced RAG, in which you can massage the query, you can rewrite the query, you could do the query expansion as well in the retrieval stage, as well as post-retrieval stage, in which you could re-rank your results, summarize your results, or as well apply the fusion of multiple retrieval algorithms. I'm sure we can also speak a little bit about the modular RAG here, because I'm sure people have been experimenting with DSPY and also, for example, Storm and other modular techniques in which you could improve the quality of your RAG solution. So overall, the idea is that we want to improve the retrieval quality so that we can provide more contextual content to our LLM to make sure that our responses are relevant. So we could work on our chunking strategy, we could fine tune our model, we could rewrite our queries differently, and overall we can work on our retrieval strategy. So we would be seeing some of those in the workshop today as well. So while I'm at the topic of RAG, if you're struggling to implement your RAG solution because you don't want to kind of share your data with the cloud, so Quadrant has launched about 2 weeks ago, like a Quadrant hybrid cloud, in which we let you preserve your data privacy, along with giving you unified management interface control for the ease of usage and control, of course. And with that, you can also leverage all the amazing features I spoke about in the previous slide of Quadrant. So if you want, you can check this out more on the given blog in the link. So coming back to the RAG once again. So obviously, in my opinion, maybe RAG is one of the most neatest implementations of artificial intelligence in the current time, especially for the knowledge management. We would be building that today, but of course, there are some core challenges. So there was this article published, I think, some time ago, which talked about some of the pain points that you would often encounter with when you're implementing your own RAG. Also came up with some solutions. So of course, if you don't want to go through the article, although the link is available, the crux is that you should work on cleaning up your data. You should focus on the data processing, give retrieval algorithm love, and focus on your models embedding as well as LLMs as well. So again, there are several different ways in which you could work on the RAG performance improvement. So as I said before in the previous slide, data cleansing is the first one. Of course, you can add more metadata to your data to help it retrieve the most relevant content for the content retrieval stage. You can work on advanced chunking algorithms as well. You could work on kind of experimenting with embedding models, different ones, as well as the custom one, the fine-tuned ones as well. You could play around with retrieval window size, sometimes providing it less documents or more documents as well. You could play around with indexing algorithms as well. So you could play around with Inoi, FIS, or HNSW. Multi-indexing is another way you could improve your RAG by using dense as well as sparse vectors. Needless to say here that with so many different choices available for large language model, that is another thing that you can fine-tune in your RAG pipeline. And last but not the least is the re-ranking. Of course, re-ranking is de facto when you want to improve your retrieval for your information retrieval systems. So today we would be focusing on experimenting with chunking strategy, embedding models, retrieval window size, and large language models. So of course, when we speak about the information retrieval system, evaluation really comes handy. And why should you evaluate? I mean, I don't need to convince you for that. We need to have evaluation in place to establish the trust and reputation and confidence of the team, to correlate the outcomes with respect to your use case. Of course, you want to also validate that your application avoids common pitfalls as well. It could be something useful to make a criteria for a go or no-go decision. And if none of these are applicable, I mean, it can still provide you with a roadmap for improvement for the future. So while we're talking about evaluation, I think that's a perfect spot for Deanna to take over and tell us more about Quotient AI.
Awesome. Thank you, Atita, for the perfect setup. So when we're talking about evaluation of RAG, this is where Quotient comes in. So Quotient enables developers to rapidly build the best AI products for their particular use cases. Our tools power AI product evaluation using specialized datasets and frameworks, and these can be customized and tailored to your organization. Our platform solves the challenges of evaluation management, version control, and orchestration, and it streamlines assessments of prompts, models, and RAG configurations. Quotient accelerates the experimentation process. So all you need to do is bring your evaluation dataset that contains real-world examples of what your AI solution is supposed to be doing. So these could be real-world examples of questions and their ground truth answers. And even if you don't have an evaluation dataset, Quotient can help you get started by building an evaluation data set for you. either from data that you may already have or starting from scratch and synthetically generating data that's realistic to your use case. We also have a number of Quotient-created starter datasets that can cover use cases like customer support chats and product catalog question answering. So once you have your evaluation dataset, you can quickly experiment and iterate to optimize your RAG solutions. Next slide, please. So how does it work in practice using Qdrant and Quotient together? So once you have your vector database containing your documents or your knowledge store, you can then populate your evaluation dataset by submitting queries to your Qdrant database to return the contexts from the LLM. And then you can then submit your evaluation dataset to Quotient, and Quotient will then handle the full orchestration from there, including the prompt formatting, the execution of the LLMs, and the metric computations. After you submit your evaluation run, all you have to do is sit back and wait for your results to get back to you. So to see it in action, that brings us to the workshop. So for this workshop, we're going to walk you through how to build a RAG system using Qdrant, and then we'll show you how to make evaluation-informed changes to your RAG system using Quotient so that you can then optimize your RAG performance. And for the sake of time, we've executed the notebook ahead of time, so we'll walk you through the code and the outputs. And with that, I'll hand it back to Atita.
Perfect. Thank you so much for setting the stage. And of course, there are some important links I would like to mention before jumping onto the notebook itself. So I'm using Qdrant Cloud and for this presentation. It would make sense for us to quickly look at how Qdrant Cloud looks like. If you have not set up your account, it would make sense to sign up for it. I'll show you in a minute why does it make so much sense. If you want to check out more about Quotient AI, there is a link provided here and also in the notebook as well. If you want to check out more about Qdrant, again, the links have been provided in the notebook as well. It would make sense to set up a virtual environment to try executing this notebook. The project or the notebook that we're going to be walking you through with is Poetry enabled. So all the dependencies have been managed through Poetry. Also, it's a good idea to look at the environment file. So we are providing an example environment file, which would consist of the Qdrant URL. Of course, that's not the only way you can run it. I would be showing you further different ways in which you could connect to Qdrant. But provided if you're using Qdrant Cloud, it would make sense to provide your URL and your API key as part of the environment file, as well as the Quotient API key as well. So apart from that, I think time to jump onto the notebook. So as you can look at the table of contents, we're going to be introducing you to RAG, which I think pretty much we've done. We would be setting up the environment. We would be setting up and connecting to Qdrant. We would be preparing the data for the retrieval or, for example, for building our RAG solution today. I would also be showing you the evaluation data set that we would be using to evaluate our RAG pipeline. As part of the sixth step, we would be building and evaluating the RAG pipeline. And of course, that's where the Quotient AI comes into the picture. So we would be setting up things with Quotient AI, and Deanna is going to be walking us through the optimization of the RAG pipeline through rapid experimentation. And finally, she would close with some conclusion and some kind of key takeaway thoughts from this. So as I said before, we've introduced RAG already. So this is the part that we're going to be importing all the relevant packages. Of course, we need to import Qdrant as well as, because we're using environment. So everything goes in here. We load our environment file. So as I said before, there are different ways in which you could use Qdrant Cloud. And saying that, I think I wanted to show you how Qdrant Cloud would look like. I'm using my personal free cloud cluster. That's the one that's free to available to use for you as well. I would be sharing the QR code later in my slides as well. So once you log on, there's a nice, decent dashboard that you can look at where it kind of tells you the current state and everything. Apart from that, if you were wondering like how much data can I really store in that 1 GB cluster, as you can see, like I'm using it actively for all my rapid RAG experimentations. So I have pretty much a lot of data here. So I think if that helps you answer the question, coming back to how you can connect with Quadrant. So provided if you are running only in experimentation mode or in the notebook, it would make sense to connect with Quadrant client in memory. I'm using Quadrant Cloud, so I would provide my Quadrant URL and API key, which I'm going to be reading from my environment file, and I'm going to be connecting to my Quadrant Cloud. If you are a fan of Docker Hub, we are pretty popular there as well. It would make sense to download the image and run Docker locally and connect to a localhost 6333. So it is a good idea to know some connection level operations as well. Provided if you're creating a collection, you would define a collection name, and this is going to give you like all the information about all the collections that exist on this cluster. As you can see, you've seen the kind of visual part of it in my UI. So I have about 8 collections already on my cluster. If you want to get specifically information about one cluster, you can provide it the collection name and you can collect the information about it. Provided if you want to delete the collection, for whichever case, you can provide the collection name and delete the collection as well. One of the other things that's very interesting when you're building a RAG solution is obviously working with different embedding models. So we're going to be using FastEmbed in this case. And if you've not heard about FastEmbed, the link has been provided here. It provides you with a seamless embedding creation for your generative AI application. And it pretty much supports plenty of models. 15 of them are listed here, with support for dense vector models as well as the sparse vector models as well, which could help you build the hybrid search solution as well. These are some FastEmbed specific operations. In case you want to use the default model, which is BGE small, you just need to initialize the embedding model equals to text embedding, and pretty much it would initialize the default model for you. If you want to try out different models as listed here based on which ever context is relevant to your use case, you could provide the model name and the max length, which is essentially the dimensions of this model. And you could customize the model based on your choice. You can verify if the chosen embedding model is reflected for your use case or not by embedding model equals to embedding model dot model name would basically display the name of the model being used. So talking about the data set that we're going to be using today to build our RAG solution. So we're using the Quadrants documentation as our data set today, because I feel like the knowledge management is probably one of the neatest use case that we can show how relevant can RAG be for any of your generative AI applications. So in this case, what we try to do is that because I've already scraped the data from the markdowns and have stored them as a Hugging Face data set, I'm going to be connecting that. And I have about 240 documents, which is what I'm going to be using today to build this RAG. So just to give you a flavor of how the documents are going to look like, obviously you have everything for one article being present here. So they're pretty long. Of course, it would make sense to chunkify this text in slightly bit more bite-sized pieces so that embedding model as well as LLM can have access to more relevant information. Coming to the evaluation data set part, of course, Quotient can also generate that for you. In my case, I've used a couple of different ways in which I've built this evaluation data set. And you're in luck because that's also part of this repo as well. So if you check out the folder with the synthetic question answer generation, this is where you would find techniques in which you can generate your own data set for evaluation. So I load that as well in this notebook. So this is how some of the input text and answers look like, which is going to be providing us with the ground truth of verifying if the answer generated by our RAG pipeline is correct or not. So as we highlighted before in the slides as well, we're going to be experimenting with different aspects of RAG pipeline, and we would be trying things out with, for example, chunk size, chunk overlap, trying things out with different embedding models, and also the retrieval window. That's the part that Deanna is going to be covering. So we have a couple of logistics methods here. One is add documents, which essentially helps us define and ingest the document chunks into our Quadrant collection based on the settings provided, the chunk size, chunk overlap, embedding model, And the retrieval window is going to be used in our next method, in which we're going to be defining the collection name from which we're going to be retrieving the relevant data for our given query. And based on the retrieval window, we're going to be retrieving the relevant number of documents. So overall, at this method, we're defining the text splitter, which is essentially like the text splitting strategy. Of course, that's like another moving piece which you could experiment with. There are plenty of text splitter ways in which LangChain can help you define this. You could write your custom one as well. But as of now, we're using recursive character text splitter in this workshop for the simplicity. So we process our document content as well as the metadata to be added with our vector points. And it's just about client.add collection name and providing the collection of metadata as well as the document content. And this line basically sends all your documents to your Qdrant collection. So that brings me to the point where Deanna's part is there. So she would be helping us how we would be leveraging these logistics methods to help us build RAG and help us build an evaluation around our RAG solution. Deanna, over to you.
Awesome. Thank you. So now that we're set up with Qdrant, we still have to get set up with Quotient for the evaluation piece. And so it's important that you've got your Quotient API key stored as an environment variable prior to instantiating your Quotient client. And in order to get a Quotient API key, you'll have to have an account with Quotient, which will give you a username and a password. And if you would like to have an account, you can visit our website, quotientai.co, and there's a form there that you can fill out to join the waitlist for our beta release. So in this cell here, we are loading in the Quotient client and instantiating it. And now that we have our Qdrant side of things set up, all we have to do is query the Qdrant database to populate a context column, and this is the context that an LLM will be using to inform the answers that it outputs to our questions in this evaluation data set. So once you have your evaluation data set up with a context, the only other thing that you need to run an evaluation job with Quotient is a recipe. And a recipe is a combination of a prompt template and a specified LLM that you'll want to be testing. And with Quotient, we support a variety of different LLMs. We're constantly monitoring for new LLM releases. So as things become available, we'll add them and support them on our platform. And if you also have your own LLMs that you've perhaps fine-tuned, you can also bring your own endpoint. So before we get into the evaluation, it's important to take a step back and think about what it is that we're optimizing for. And for this particular use case, we're doing question answering on Qdrant's documentation. So while it's generally important to have helpful answers to questions, it's arguably more important that the answers don't have any misinformation or misrepresentative information that might lead Qdrant's users astray. So with that in mind, the thing that we'll want to optimize for here is minimizing our hallucinations in the LLM outputs. So given that, the metric that we'll be focusing on is faithfulness, which is our hallucination metric here. But in addition to that, we'll be looking at a number of other metrics, including the context relevance and the chunk relevance. And these are both metrics that are more focused on the retrieval side of RAG. So they are measuring the quality of the contexts and how helpful they are to answering the question. And for chunk relevance, looking at the amount of the document returned that was ultimately useful. Then, of course, we've got our faithfulness. And then we have Rouge, BERT sentence similarity, and BERT score. And these three are more focused on looking at the quality of the answers in comparison to the ground truth, trying to measure how well does the LLM adhere to the answers that we're expecting. But Quotient also supports a number of other metrics beyond what we're going to go over here, including some LLM as a judge metrics, and you're also able to define your own LLM as a judge prompt if that's relevant to you. So this function here, the run eval function, this is where we will be executing the evaluation. We start by taking in the collection name for the quadrant vector database. We take in the recipe with the prompt and the model, and we specify the number of documents that we want to retrieve from our database. And so first we go through, we query the database, populate our context column. And once we've done that, we can then submit our evaluation data set to Quotient. And after you've submitted an evaluation data set, you can then tell Quotient what type of task you are evaluating on. And so in this case, we're doing question answering. And then you're ready to create a job. And the job will take in the recipe and as well as the specified metrics that we're going to be computing here. Once you've kicked off the job, you can monitor its progress. And once the metric computations are completed, and then you can get your results back. In this particular case here, we're waiting for the jobs to complete. But if you wanted to, you could actually kick off a number of jobs all at once and have them run in parallel. So we support that as well. But so yeah, after you get your results, you can then start to look at aggregated statistics about the metrics. So with that, we'll jump right into it. So for our first experiment, we're starting from scratch right now. So we want to think of some relatively reasonable parameters that we'll want to use for our RAG setup. And in this case, we've chosen BGE small for our embeddings. And then we'll be setting our chunk size to 512, our chunk overlap to 64, and we'll be retrieving 3 documents for each query. And the LLM that we'll be using to generate our answers is Mistral 7B Instruct. So in this cell here, you can see that based on that configuration I've just described, we are setting up the collection with Quadrant, populating the vector database. And you can see that we've returned 4,500 documents or vectors that are populating this database. And these were all broken down into chunks from the original 250 or so that you saw earlier. So now that we've got our database set up, we now have to create a recipe so that we can tell Quotient what prompt we want to use and what model. And so here we're, like I mentioned, using Mistral. And you can see here in, we're using a prompt template that's pretty generic or standard. We're just pulling in the question, the context, and we are prompting the model for an answer. So with our evaluation data set ready and our recipe ready, we can kick off an evaluation. And if we scroll down, you can look at the outputs. These are just aggregated statistics of our output. And off the bat, if you look at the second row in the mean, the chunk relevance is actually quite low at just 0.46. And even the context relevance at 0.72 is perhaps a little bit lower than we would like it. And maybe more notably, the next row down in the standard deviation, we're seeing really high standard deviations or variances in this metric. So to look at what this looks like in practice, if we look at some specific outputs for rows in our evaluation data set, these are examples where our faithfulness was the poorest. And so faithfulness, again, is the metric that we're optimizing for here. So when faithfulness is bad, perhaps unsurprisingly, you can also see that the chunk relevance and the context relevance are also pretty low. And this makes sense intuitively because you're essentially giving the model some information that isn't helping it ultimately answer the question. So it's perhaps starting to generate text or answers that don't adhere to what we are looking for and don't adhere to the actual documents that we've retrieved. So in our next iteration, we're going to try to work on improving our contexts, improving the documents that we're retrieving. And so it seems as if we are not giving the model enough information to base its answers off of. So my hypothesis is if we increase our chunk size, then we'll be giving the model more information to base its answer on and perhaps get better results. So in experiment 2, we try just that. So this time, we're going to use the same embeddings, the same BGE small model, still retrieving 3 documents and still using Mistral, but this time we'll double our chunk parameters. So the chunk size goes to 1024 and our chunk overlap goes to 128. So again, we set up a new collection and we can kick off a job. So if we skip down to the plot that's comparing our 2 experiments, just a little bit further, perfect. So you can see here, this plot is showing the average score across our evaluation data set for the first experiment and the second experiment. And our context relevance has gone up, but the chunk relevance and the faithfulness has actually gone down. You can also see that the Rouge and BERT scores have gone up as well. And this is probably a result of the fact that the context relevance has increased. So we are getting a little bit better performance in that regard. But the fact that the chunk relevance has actually gone down is telling me that the information, the chunks that we're giving the LLM are actually now containing less useful information proportionally. So we're giving it ultimately more noise, more like unnecessary information, and that's bringing our faithfulness down as well. So what we might want to try next instead, we still want more context, but we don't want large and like irrelevant chunks. So maybe we can go back to the smaller chunk size we were trying, but this time increase the number of documents we retrieve. And so that is just what we do in experiment 3. So this time around, we are using the exact same setup from experiment 1. The only difference is we've gone from retrieving 3 documents to 5. So here you can see we don't have to recreate the quadrant collection because we already have it there. And so we can just kick off an evaluation run off the bat and set our number of documents to 5. So skipping down to that plot again. So you can see now that when we retrieve more documents, but with the smaller chunk sizes, we're actually improving our chunk relevances, we're improving our context relevance, and most importantly, we're improving on our faithfulness as well. So we've got our best scores to date on all 3 of those. Worth noting that the Rouge score and the BERT score are actually both lower for experiment 3 than they were for experiment 2, but only marginally so, and especially considering that faithfulness is the metric that we're optimizing for, I think that we'd still conclude that experiment 3 is our best run to date, our best set of parameters. So up to this point, we've been focusing a lot on how to modify these specific retrieval strategies, but we haven't touched the embedding model itself. And the embedding model is fairly important. It's essentially the way that you are encompassing the semantic meaning, the information behind your documents. And so this time around, we're going to try out a new embedding model to see if perhaps the sentence transformers model, the all mini LM, might better encompass the domain space and the terminology used in our documents. We'll use the same exact parameters that we found to be the best in experiment 3 with the chunk size and overlap and the number of documents. So again, we set up our quadrant collection and we kick off an evaluation run. And so if you scroll down to the document, to the plot. So you can see here that it looks like across the board, the fourth experiment actually performed worse. So it was worth a shot, but it seems like BGE small is still our best embedding model here. Certainly worth exploring and trying out new ones, but you might find that the best lift to your performance in this regard would be to fine-tune your own model that could learn the specific jargon in your data set, in your documents. So for our last experiment, up to this point, we've been doing a lot of experimentation with the retrieval side of RAG, but we haven't really changed anything up on the generation side of RAG. So this time we're going to swap out our LLM and let GPT 3.5 have a shot. And again, here we're using the same best parameters that we got from experiment 3. So this time, since we're changing up our model, after we have created our new quadrant quotient, we now have to create a new recipe. And so this recipe will be using the exact same prompt template that we did before, but instead we'll be using the GPT 3.5 turbo model. And so we can kick off our final experiment here. And if we go down to the final plot that's generated, so it looks like across the board, GPT 3.5 outdid Mistral 7b. And it's worth noting the chunk relevance and the context relevances are the same between experiment 3 and experiment 5. And that's just because we haven't changed up the actual retrieval side of the RAG pipeline. So you'll only notice differences in the metrics that are measuring the quality of our outputs of the generative side. So those would be these last 4 here. Most notably, our faithfulness score is the highest by about like 0.03 points. So a notable increase. And same with Rouge. Rouge was significantly higher. So our final experiment here using GPT 3.5 has lowest prevalence of hallucination and overall best performance. And so I think we're off to a good start at getting to a better RAG solution. So in conclusion, this table here is summarizing the different experiments and the parameters that we have tested out, as well as the average metrics that we're getting for these experiments. And there's certainly many more experiments that can be run. We still have fairly poor performance on the retrieval side of RAG. So we may want to explore, like I mentioned, fine-tuning your own embeddings, or using a different retrieval strategy. As I alluded to earlier, the standard deviations or the variances in our context relevance metric tells us that some documents might require more information than others. And so we might want to consider some kind of a dynamic retrieval strategy to see if we can get improvements there. Then, of course, there's all of the experimentation you can do on the generation side. Changing up your prompts can have a really big impact on the quality of your model outputs. And there's always parameters like the model parameters like temperature or the top P and top K that can have a big impact as well. So overall, I guess you can see how starting from 0, you can put together an improved RAG system and make evaluation-informed changes throughout your experimentation to help inform that process. And if you're interested, you're welcome to request access to Quotient on our website. And if you'd like to learn more, we also have a series of blogs where we highlight some of our research that we've published as well. So thank you. And thanks, Atita. I'll hand it back to you.
Cool. That is amazing. And I think, I'm sure, it was really insightful for me as well when I saw it for the first time. And I love that how you built your hypothesis around the result set. And I'm sure it would be useful also to the attendees today. I think we do have some questions. Maybe the one which I feel like worth answering at this point in time is about the code that has been displayed here. This is already open source as part of this repo. We would be sharing that along with hopefully the recording of this session as well, along with the slides as well. So you can look at this example and the others as well, where we've experimented with other evaluation tools as well. Other than that, I think, as promised before, if you want to kind of request Quotient AI for the API key, or if you want to request your own free cluster at Quadrant, it makes sense to scan these and request them. So I think we do have some questions at this point in time, apart from the one I shared before. Um, so the question says, we're storing embedding of our existing data in Quadrant Cloud. How can we update the embedding when we come up with new data and its embedding? So I think, obviously this question is for me, so I'll take it, Deanna, if you don't mind. So yes, so we would have to update this as well. And it is a good practice to delete the existing collection in the event that it would get overwritten. Or so I would suggest that you would delete the collection as I showed before as well on the notebook, if I understand the question correctly. Um, and for this particular notebook, what we were doing is we were creating different collections on the name of the experiments that we ran. But going back to the part that I spoke about earlier, uh, this one. So it would make sense if you're trying out a different embedding model, for example, it would make sense to delete it and create the collection based on the new embedding model. So if you're using FastEmbed, initialize your new embedding model, and then you can process your embeddings again. I hope that answers the question. Um, okay, the next one is hello from France. Whoa. Interesting. So I would like to know realistically, what hardware should I use if I want to run Quadrant and serve 10,000 files, for example? So I would say that again depends on the kind of like vectors, how large they're going to be. So if you're talking about 10,000 files, again, you did not specify as to how big each of these files going to be, depending on what is going to be your chunking strategy, or if you're going to be serving them as part of like one vector, which is going to be storing maybe one vector per file is what I'm assuming. So 10,000 vectors, I think it should be uh, pretty much feasible on the free instance as well. So I think I would give that a try, unless there's more context around the kind of documents that you're planning to serve on your vector collection. Okay, and I guess there's another one which says, please discuss about issues 502 connection refused when connected in proxy environment. I am not sure what this is. Is this, so I'm assuming it's probably related to Quadrant as well. And I, for some reason, have no idea about it. But I can, because we have reference video here, maybe I can request someone to add more context, and I can update the YouTube video with this question as well as the answer, if that helps. So other than that, I got a system with 3.5 million vectors, and its sports result at 14 millisecond. Oh, wow. Thank you for this amazing feedback. Definitely makes my day, and the others. So I would convey this to our team as well. Okay. So looks like we have no more questions, which is interesting. I think I have maybe a couple of questions for Deanna. I've been wondering, first of all, is that you mentioned about obviously the strategy here that we could run. And you mentioned also about some of the other metrics as well. So do you have any guideline per se which lets us pick the metrics which are going to be relevant for a particular given use case? Maybe if you could talk about it a little bit, I think that would be pretty relevant to the attendees today.
Yeah, of course. So for users that get set up with an account, we have some documentation where we have some detailed walkthrough and description of all of the metrics that we support. And we also show examples of like what the inputs and outputs could look like. So that's there to help guide you when selecting your metrics. I think also in general, I mean, for anyone that's using Quotient, we always welcome people to reach out and ask questions, and we're always more than happy to help guide the experimentation process. So yeah, I hope that answers the question.
Yeah, I think that's a pretty good one, and I think also worth to check out the documentation from Quotient as well. Another one, probably, which I've seen in other like use cases. Some of our customers have also brought this kind of question before. So you started with, I think, 512 for the experimentation part. Is there a way we could figure out like the relationship between how big should be a chunk size for the given use case, maybe? If you have any
So
insights about it.
yeah, so it's certainly challenging because it's going to be very dependent on the use case. If you are expecting your answers to be very long and very detailed, then you're probably going to need more information to help inform those answers. So you'll probably need larger chunk sizes. Um,
Mhm.
or if you have documents that have like very long chains of thought where maybe I don't know, it takes several paragraphs of information to get the full answer to the question, then those would be contexts where like or situations where you'll need larger contexts and larger chunk sizes. But if the nature of the questions that you're asking are going to be very to the point, fact-based, a lot of times those are things where you can really make that chunk size small and optimize it to return the most relevant pieces of information. Obviously there's always like a battle between like you make it too small, then you lose out a lot of the context where the model can understand what this
Right.
particular fact means. But yeah.
Yeah, I think that's a pretty good explanation, and I think I would probably figure things out the similar way as well. I think the similar thing also goes for chunk overlap as well, and also maybe the number of docs as well.
Mhm.
Uh, I think I have a feeling that we might have to repeat this notebook maybe with the with the advanced formats of the RAG solutions that we discussed in the slides before as well. It would make total sense for that. Um, I think apart from that, do you have any questions for me?
Well, I mean, I just want to say how much of a pleasure it is working with Quadrant. It really works seamlessly and integrates into our evaluation framework here. And also just call out that it's been truly a pleasure working with you, Atita, as well. So thank you so much.
Likewise. So great. I think this has been a real pleasure hosting you here. And I'm super delighted that this was successful. And I hope it was also useful and knowledgeable for the attendees as well. Um, I don't know if, is
Looks like
that a
we might have
question
gotten one
before?
more question.
Yeah, seems like this could be for you.
Um, yeah, so I don't think that necessarily. So, well, let me read out the question. Would you assume that chunk size of 200 is a bad idea? I see in an experiment that I have a hard time getting relevant answers. So I don't think that using a chunk size of 200 is necessarily a bad idea. I think that it might be the valid solution or the optimal parameter in some use cases. Depending on what your use case is, it might be that um, and also depending on the nature of like the relevance of your answers. If it's that you're retrieving documents that aren't relevant at all, then maybe you do need to try increasing that. If you are getting some things that are relevant and some things that aren't, maybe you try getting more documents or setting some kind of other type of dynamic retrieval strategy. Um, the other thing to keep in mind is that the things that you're retrieving are only going to be as good as the embeddings that you're using. So if you have a lot of things like acronyms or terms that don't typically get used in the language you're working in or in English, then you might have a hard time picking those up because the embeddings ultimately will just see something it doesn't recognize and essentially treat it as nothing. And so that's actually a situation where Quadrant's hybrid search would come in handy.
Absolutely, absolutely. So I was actually going to also maybe use that as a hook because that's been asked before. So I would highly recommend you to check out this repo where not only have we experimented with different evaluation tools, but also like different RAG strategies as well. So I mean, it would also be shared as if you're registered for the session, you would get this as part of like the afterwards. The recording link and the presentation as well as the Git repo link. So hopefully that would help you to experiment and might as well improve your RAG. So other than that, I guess we have no more questions. Okay. So looks like that should be it. I hope it was useful for Quotient. It was super useful for Quadrant, of course. And thank you for contributing to our Git repo as well, Deanna. And I hope we would see you again with maybe more advanced format of RAG and then evaluating that RAG with Quotient. And looking forward to repeat this series once again. It was absolute pleasure to have you on board.
Thank you so much. And likewise, looking forward to what's next.